Hello everybody, paper 3 now from Edexcel's June 2023 series of GCSE higher tier exams. So paper 1 and paper 2 have been and gone. Annoyingly and maybe slightly unfairly you may argue, as a department we seem to believe that paper 3 tend to be slightly nasty. That said, it is the last one, so let's see how we go through them. I might show a few different methods, different questions, depending on the time and whatnot, but anyhow, any questions further you have, either ask me in class, email me, or leave comments on the video. So without further ado, I'm just going to get straight to it. Let's have a look together, pick through question number 1. 1a is laws of powers. So simplify m squared cubed. Now, that means m squared times m squared times m squared. Basically, it's that 3 times. The reason it's 3 times, and the reason I'm doing it the long way, is to emphasize this law. When you have 2 powers next to each other, it's 2 times 3. M times m times m times m times m times m. The new power is m to the power 6. It's a very common mistake to do 2 plus 3, which is 5, but no, the power of m needs to be 6. This one, simplify x to the power 5 times x to the 8. That's x times x times x times x times x times, I can't even be bothered saying it. This one is a case of doing 5 add 8. That will give x to the power 13. And then the last part, part C, is expanding. So 4p multiplied by p squared, well, p times p squared is p cubed, but we're going to have 4 lots of that. So it's 4p cubed, plus sign, so we take a plus. Numbers first, 4 times 3 is 12, then p multiplied by another p gives us p squared. So that's question 1 done and dusted. Let's have a look at question 2. So, this one's a more problem-solving one. It's about Johnny wanting to know how much coffee he'll need for 800 people at a meeting. So let's just talk it through step by step. So this meeting, 800 people, okay. Now, they're drinking coffee, and he's assuming that 68% of those 800 people will drink coffee. And each person who drinks coffee should have 2 cups, 10.6 grams of coffee is needed for each cup of coffee. So using these assumptions, work out how much coffee he needs. So not all the people will be drinking the coffee, it's just 68% of 800. So that means 68% of 800 is 0.68 times 800. We've got 544 coffee drinkers to consider. Each person who drinks coffee will drink 2 cups of coffee. So then I'm thinking we could work out how many cups this is. 544 times by 2, because it's 2 cups each, we need 1088 cups, 1088 cups. However, each cup needs a certain amount of coffee inside it. 10.6 grams of coffee for each and every 1 cup. So if we've got 10,088 such cups, that will be 10.6 multiplied by 1,088, which will give us 11,532.8 grams. Don't lose a simple mark. It's asking us to give the answer to the nearest gram. So if we round this off to the nearest gram, that'll go to 11533, because the 8 will force the 2 to round up, because 8 is 5 or higher. So our answer is 11533. Part B, Johnny's assumption is wrong. In actual fact, 72% of people will drink coffee. How does this affect your answer to part A? Well, he thought 68% of people drank it. 72% is higher, so that means more people will be drinking coffee, therefore more coffee will be needed. So in other words, this answer to part A would actually increase in truth, because he's going to need more coffee. So to put it simply, the value will be higher. Let's have a look then at question 3. So ACF and ADG are straight lines. BCD and EFG are parallel lines. Show that ACD, this triangle here from A to C to D, is isosceles, and give a reason for each stage of your working. So let's pick this out step by step. So ACD. So I'm just going to highlight ACD. ACD is this triangle at the top in blue, like I've said. This is the angle where we can work out, first of all, I'd say, because we're told from A to D to G is a straight line, and we should remember that angles on a straight line add up to 180. So if that's 110, and that's the other side on a straight line, then this angle here will be 180 minus 110, which gives 70. So that's the first thing we can say. So if that's 70, And it says give a reason for each stage of your working. So let's write down something very clear so the examiner has no choice but to award you full marks. Play the game. ADC is 70 degrees. Angles on a straight line add up to 180. Get the working in. Next, let's think about this angle related to this angle. If I just draw in like I have in red, ACF and EF and BC there are two parallel lines. This, in my mind, these red lines make an upside down, sort of back to front F. I think of as being F angles. Some teachers might say them as T angles. Essentially, what we need to spot is this angle at the bottom, 125, and this angle here will be the same. That's going to be 125 degrees, but we need to remember why using our angle facts. An F angle, if you like, two angles which form from a straight line, then two parallel lines forking off from that, which meet on the same side of those parallel lines, will always be equal, and these are called corresponding angles. So the reasoning is BCA is also 125, then you need to just say corresponding angles are equal. If you wanted to, I suppose you could say it's a corresponding angle to angle EFC. Next, we have another straight line here, BCD. And because we're interested in this triangle ACD, it benefits to work out this one here. Angles on a straight line add to 180, so this one will be 180 take away 125, which gives 55 degrees. So this angle in blue, 55 degrees, put the reason. ACD, because it goes from A to C, then to D, is 55, and that's because angles on a straight line add up to 180 degrees. Finally, we should know that the angles in a triangle add up to 180 degrees as well. We know these two here, so we can work out this missing one by adding these two together and taking the result away from 180. 55 plus 70 is 125. 180 take away 125 is again 55 degrees. So then we can say CAD is 55 degrees with reason, and then also angles in a triangle, getting every single reason you can in, because that adds up to 180 degrees. Remember what you're trying to show though. We're trying to show that ACD is isosceles. So what's one of the defining characteristics that makes a triangle be isosceles? One aspect is that the triangle has two sides of equal length, yet another way that defines an isosceles triangle, it has two angles that are exactly even in size. This one does, because it has two angles, not three, that are exactly equal. Remember, if it would be three angles, it'd be equilateral triangle. Two angles are the same, it's isosceles. We've proven it now, so we just need to make our concluding statement and finish. So then we say something like, therefore, this is just what the dot 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 means, therefore a triangle ACD is isosceles, and the reason here, to prove to the examiner you really mean business and know what you mean, because it's got two equal angles in it. That's probably slightly overkill for question 3, but better doing that than not writing enough and losing marks. Question 4. It takes 14 hours for 5 identical pumps to fill a water tank. Let's picture this first of all. Water pumps. A pump that pumps out water. Imagine like a big tap almost. We've got 5 of them. Here they are. Quite old-fashioned devices. So each one of these 5 identical pumps is working for 14 hours. And that's how long it takes combined to fill the water tank. So 14 hours for each one. Imagine how much equivalent work or hours that would be if just one water tank were working. 14 hours for that one, plus another 14 for a second, plus 14, plus 14, plus 14. For one pump, that's equivalent to 5 times 14, which is 70 hours worth of work. That's how long it'd take for just one pump. So figure out what it'd be for just one pump first. This question here, though, is saying how many hours it would take if there were 4 pumps. So if imagine one of them disappearing, like so, then imagine 70 hours worth of work shared out now between 4 pumps. So it's not 70 hours just to itself, this can now be divided equally by 4. 70 divided by 4 gives 17.5 hours. So each pump would be working for 17.5 hours. Double check, does your answer make sense? 4 pumps should take longer to fill the tank than 5 pumps, so my answer should be bigger than 14. Is it? Yes, 17.5 is bigger than 14. My answer makes sense, so I can move on to the next question. Question 5 is about HCF, highest common factors, and lowest common multiples. This time it's in terms of prime factors. Here I'm going to use a Venn diagram, but first of all, let's write out what A and B are in longhand. A is 2 times 2 times 3 times 3 times 3 times 3 times 7, and B is 3 times 3 times 7 times 7. So if I write them in red and blue, in the long way, we have this. Also, what we can spot is some numbers will appear twice. So for example, we can pair up some numbers in the red and the blue. So I can pair 1 3 with another 3 here. I can't pair the second blue 3 with another one, or can I? In fact, yes I can, because that spare 3 has another spare 3 to pair with. So next I'm going to pair another 3 and 3, so it's 2 pairs of 3. And finally what I can do, I can pair this lone 7 here with either one of these blue 7s. So I've got 3 pairs of numbers that appear in each list. Now I'm going to get the Venn diagram, a red circle to represent number A and a blue circle to represent number B. So in the bit which is just for circle A, that's just going to be the numbers that are included in number A only. So this 2 and that 2 have not paired together with anything to do with B. So 2, 2 and a 3 and a 3 can live on their own just in the A circle like this. In the same way for B, I've got a lone 7 which can just stick on its own in only the B part over here. These numbers here, because we're in both lists, these can go in the middle. Now a common mistake is to think, well, I've got 2 3s there, so I'm going to put 2 3s in the middle, another 2 3s and 2 7s. Do not do that. Just put, for each pair, just put the number in that pair in. So 1 pair of 3s, just 1 3. Another pair of 3s, a second 3. 1 pair of 7s, just put 1 number 7. So the middle bit, 3, 7 and 3 to represent those 3 pairings of numbers. Now we've got it set up, we can tackle part A, the highest common factor of A and B. Common is the key word. Common relates to the numbers in the overlapping bit. To work out the highest common factor of A and B, what we're going to do is just multiply the middle numbers in the Venn diagram together. That's all we need to do. So the highest common factor is 3 times 3 times 7, which is 63. The lowest common multiple, again we can use a Venn diagram, but this time, instead of just multiplying the middle numbers together, now what we need to do is multiply all the numbers together. So it's 2 times 2 times 3 times 3 times 3 times 7 times 3 times another 7. This time that gives us an answer of 15,876. Question 6 is about lava, but don't be scared, it's only a question, even though lava is pretty damn hot. Lava flows from a volcano at a constant rate of 11.9 cubic meters per second. That's a lot of flow. How many days does it take for 67,205,600 meters cube of lava to flow from this volcano? Give your answer correct to the nearest day. So where to begin? Let's just think about what this unit here means. 11.9 cubic meters per second. What this means in sort of more plain English is that 11.9 cubic meters is leaving the volcano in each and every single second. That means what per second means. That amount in 1 second. However, obviously, it's going to be flowing for more than 1 second if it has to emit this much lava. So how many times bigger is this number than that one, essentially? So to find out how many seconds it would be, I'll have to work out 67 million and so on divided by 11.9 to work out how many times bigger this is, and therefore how many seconds the volcano must have been spewing lava for. So if I set the question up like this, in terms of proportion, if it's 11.9 cubic meters in 1 second, how many seconds would it take to spill out this much lava? So essentially, you need to scale it up from this small number to the huge number. And like I've said a few times now, we work that out by performing a division. So this one, I'm going to do this number divided by 11.9, and that's going to give us 5,647,529.412. So in other words, to go from the red to the blue, I multiply by that figure. So in other words, I now know at least how many seconds is needed for the volcano to be flowing lava for. In other words, it must have been emitting lava for millions and millions of seconds. So this number, 5,647,529.412 seconds. That means very little to me, because obviously after thousands of seconds we're talking about minutes. After millions of seconds we need to think about days. So here we need to give our answer to the nearest day. So let's just split this into two for a second, no pun intended, and think how we can convert from seconds into, let's say for example, hours. Well, first of all, let's go from seconds to minutes. 60 seconds makes a minute, so to convert from seconds to minutes, I can divide this figure by 60. Try it in your calculator, you should get this. 94,125 and so on. To go from minutes to hours, because there's 60 minutes in each hour, I can now divide this by 60 again to convert to hours. That tells me it's about 1,568 hours. Then to go from hours into days, because each day is 24 hours, I need to then shrink this by a factor of 24. So dividing this by 24, that's going to tell me how many days the lava was flowing for. So it's been flowing out of the volcano for approximately 65.4 days. Don't put that as our answer, read the question carefully. The question clearly says, give your answer correct to the nearest day. So this wouldn't round up to 66, it would round down to just 65 days. 65 days is our final answer. Question 7, we have a graph, it's a quadratic graph, x squared minus 2x minus 2. This essentially is just a memory test question. Can you remember what the turning point means? Can you remember what the root means? Well, first of all, turning point of a curve, for example, typically it's going to be a quadratic, is the absolute lowest point or the absolute maximum if it's a sad quadratic. Because this is a U-shaped quadratic, it turns here. It literally goes from going downwards to going up at this point. That's why it's called the turning point. It turns direction. So the turning point is this one here, which I'm going to put a red dot on. That's a coordinate 1 along, minus 3 down. Well, 3 down, which is minus 3. So 1 minus 3. Secondly, what is a root? A root of an equation is when, if you graph it, it's where the line, the curve of the function, crosses the x-axis. So this one has two roots, here and here, like so. But the question just says, estimate for just one of them. So take your pick and give it as accurately as you possibly can. So this one down here, each little square going along is worth 0.2 of a unit. 0.2, 0.4, 0.6, 0.7, but it's in the negative direction. This is about minus 0.7. This one is 2.7. So you could write down for your answer either minus 0.7 or x is 2.7. And those are the two roots. Just pick one for your answer. Question 8 is about the solid cuboid made of metal. So we're talking about the density of it, which is 9 grams per cm cubed, and the volume, which is 72 cm cubed. So work out the mass of the cuboid. So mass, density, and volume. This should get your sort of memory going. Mass, density, volume relates to a formula. I tend to use formula triangles. You don't have to. Essentially, the formula is the density of a substance is defined as the mass of it divided by the volume it takes up. Density is mass divided by volume, or as a formula triangle, like I mentioned, d, m at the top, v in the other corner. So we can just think about what we know and what we need to work out. So we're told the density. We know that's 9. The volume as well we know is 72. So I know v is 72. I want to work out the mass. So mass is on the top of the triangle. And so if I just colour in mass in a blue on top, then to work out what you want, just cover up your hand, cover up what you want to work out of your finger, your hand, whatever. So if I cover up M and see what's left and in what configuration, I've got just D and V remaining, D and V next to each other. Now algebraically, if we have two terms immediately next to each other, it means we multiply one by the other. So we're going to do density multiplied by volume to calculate the mass which we need. And that's all we need to do. In other words, mass is density times volume, so that's going to be 9 multiplied by 72. Use your calculator, of course. That will give you 648 grams. So 648 is our final answer for question 8. Question 9 is a percentage of a percentage question. So apparently some people are asked if they wanted a new TV. Don't we all? Well, apparently not, because only 70% of the people said yes. Anyway, never mind my opinions on it. 80% of the people who did say yes wanted a new television with a large screen. So what percentage of the people asked said they wanted a television with a large screen? So I could give you the quick answer, the quick method, but want to first of all illustrate why the method is as it is. So percentage means out of 100. So let's just picture 100 people first of all. So if 70% of people said yes, imagine 100 people being surveyed, 70% of that would be 70 of these people. So this would just be the people in this red rectangle. I'll stress again, this isn't the method I'm suggesting you use in the exam. I'm not saying sketch out 100 stick figures. I'm just trying to illustrate and make sense to you why this method I'm about to say at the end will make sense. Anyway, of these people within the red rectangle, 80% of these said yes, I want one, and also with a large screen. 80% is 80 out of 100, which would simplify down to, of course, 4 out of every 5. If you look here, we've got 1, 2, 3, 4, 5 rows of people. So 80% of these people who said yes would just be 4 rows out of the 5. So if I highlight now 4 rows out of the 5, like so, this is the total number of people that said yes and want one with a large screen. So how many people out of a total of 100, all of them, is this? Well, it's 4 rows, and in each row here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So in other words, 80% of the 70% is 4/5, which is 80 out of 100, 4/5 of those 70%. This is the direct method. So it's one percentage multiplied by another. If you try this on the calculator, it'll give you 14 out of every 25. But as this illustration shows, this would actually be 14 multiplied by 4, which is going to give actually 56%. So obviously this is on the calculator, so a percentage means out of 100 as I'm saying. So 14 over 25, I'll show you here. If I type in 14 over 25, press equals SROD 0.56, which you should know really is the same as 56%. So our final answer for question 9 is 50% of those people is the percentage we need. That's many people want a new TV with a large screen. Question 10 is about a triangle. Well, in fact, it's like 2 triangles joined into one in a sense. ABD is a triangle, and C is a point on the line from B to D, like so. We need to work out the length of DC and giving it to 1 decimal place. So DC, I'm going to underline in blue, which is this line here. So it relates to triangle ADC, but we know almost no information about ADC. We know it's a right angle, and that's 55 degrees, which on their own isn't enough information to work out what we need. So what we need to look at first is what we can actually gather from the triangle on the right hand side. You've got to be thinking the examiner's included this one for good reason, and actually that is what we're going to have a look at here. So if I just ignore ADC for a second and focus in on ABC, we can set to work thinking about what we can work out from this one. Obviously the triangle I've covered up is the one which has DC on it, and so what bit of ABC shares its information with the other triangle? Well, that's going to be the shared side, AC. So if I work out AC now, I can then use AC to return to the left-hand side triangle. So could I work out A to C? Well, this is a right-angled triangle, so it's going to be a case of SOHCAHTOA. Opposite to the 41-degree angle, I'm going to label O. So AC is the opposite side, and the longest side, the hypotenuse, is 6.8. So, as I've said, we're going to be using SOHCAHTOA. So I want to know the opposite side, and I do know the H. So to decide which one of these SOHCAHTOA triangles we use, it's always the one which includes the side we know and the side we want to know. So if I highlight these sides in particular, green for hypotenuse, yellow for opposite, and colour code these within these triangles, essentially it's the most coloured in triangle which we're going to be using. Therefore, as you can see, hopefully it's going to be the SO triangle, which is going to be sin, or better known as sine. So we want to work out the opposite, therefore we cover up the O and what remains tells us what to do. So if I cover up the O, have S next to H. Two things immediately next to each other in algebra means one multiplied by the other. So that is to say, to work out the opposite side, we're going to do sin times H. S stands for sin of the angle, so it's going to be sin 41 multiplied by 6.8. If you try this, you should get 4.4612 and so on and so on. And don't round off your answer prematurely. Keep as many figures as you can and write them all down. So write down all these figures if possible so that you don't get any rounding error in your final answer. So what I'm going to do now, I'm going to label on this length here, and then we can return to the other triangle. So the right hand side triangle has served its purpose in the nicest possible way. We now no longer need this one. So I know this is 4.46, so I'm going to add this onto the diagram. Forget now this triangle and return to the one on the left, which includes DC, which is what we're ultimately interested in. So now, if I just forget about this other triangle, cover it up like so, now we've got another SOHCAHTOA type question to work out. So if we apply the same logic, labeling the sides, relative to ADC, this one now is the opposite side to the 55-degree angle we do know, and we want to work out DC. Well, the hypotenuse is always one I'd label next. Opposite is easy, it's opposite of the angle. Hypotenuse is AD. Therefore, the other one, which I consider to be almost like the odd one out, if it's not O or H, it must be A for adjacent. So now, returning to SOHCAHTOA once again, let's highlight the sides. I know the opposite, and I want to know the adjacent. So I'm interested in O and A. Again, if I highlight these in yellow and green, colour in the SOHCAHTOA triangles, this time we see that TOA is the one to use because this is the most coloured in triangle. This time we want to work out A, so if I cover up A and see what remains, we've got O on top of T. Therefore A is going to be the opposite divided by T. So A, which is DC, which is what we ultimately want, is the opposite length divided by T. T stands for tan of the angle we know. So it's opposite 4.461201397. Again, don't round off too soon. Divided by tan 55, press equals, and we should get our answer. So if I show you here, so if I type in 4.461201397, and then type in tan 55, close the brackets, I get 3.12 and so on and so on. So my answer that the calculator gives is 3.123 and so on and so on. Read the question carefully as ever. Give your answer correct to one decimal place. That means I want to keep one digit after the dot. So it's either going to be 3.1 if we don't round up, or maybe it's 3.2. But hopefully here we can see that after the 1, it's only a 2. If it were 5 or more, we'd round up. Because it's just a 2, we don't need to. So essentially, we can cut it off after the 1. It's just going to be 3.1. And that's our final answer for question number 10. Question 11, we have a table showing some information about the heights of a group of adults. So least height, greatest height, median, lower, and upper quartiles. First of all, on this grid here, we need to draw a box plot for the information of the table. So if we're doing a box plot, we need to know the least and greatest values, the median, the lower, and the upper quartiles. We're given all these values here, so there's nothing fancy to do. The only thing we need to do is to carefully plot these in the right places on the grid. And the only thing I'd suggest to be careful for is that each 2 little squares are worth 1 unit. So taking care, if we do the 5 vertical lines first to represent the least, greatest, median, lower quartile, and upper quartile, we'll have something like this. Then to finish off a box plot, we need a horizontal line here, and then lines drawing the lower to the minimum and the upper quartile to the maximum. So to finish it off, it looks something like this. So that's part A done, just using the table of values to fill in the box plot essentially. Part B is where you need to be careful of your wording and not write down something which is too minimalistic, but at the same time don't waffle. Keep it concise and to the point. comparing the distributions of heights of the adults, the one we've just done, and the heights of the teenagers, which is pre-drawn here. If you're comparing distributions, there's two things to compare. So to compare, we need to do the median comparisons and the interquartile ranges. Always compare medians and interquartile ranges if you're talking about a box plot, and more than that, give a context to the values. Don't just use numbers, say what the numbers mean. In this case, talking about the heights, and median therefore will relate to the average height or a typical height, and interquartile range will relate to the range or consistency of heights for both adults and teenagers. So let's think about medians first of all. So the median for the adults is 177, and if we look here, for the teenagers, the median height is going to be 169. So I'm just going to add these in for visualization. And then the interquartile ranges are the upper minus the lower quartiles. Essentially, this is the same as the length of this box in the middle. So for the adults, upper minus lower is 6, and reading off here for the teenagers, we've got 171 minus 165, which is also 6. So actually, the interquartile ranges for each are also 6. So to make a comparison, we need to say that typically, or on average, the adults tend to be taller than the teenagers, referencing the medians to back up our sentence. And also, the second sentence, to compare the interquartile ranges, we mention about the consistency of the heights. So something you might want to write might look like this. Something like, in general, or on average, the adults are taller than the teens. Then use the figures to back up what you're saying. Median 177 versus median 169 for the teens. And the adults and teens' heights were similar. You could probably say the same in consistency, because the interquartile range is a measure of consistency. And back that up by saying that you know the interquartile range of both data sets is 6. If you do that, or something similar, you will get full marks. Question 12. Show that x minus 1, brackets x plus 3, brackets x minus 5, can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, and c, and d, are integers. This is a fancy way of saying, without quite saying it, to expand these 3 brackets. And we can only expand 3 brackets by doing 2 brackets at one time. We can't expand 3 at once, so just expand any 2 first. What I always suggest to my students is to expand the last 2 brackets first and work back to front. So first of all, let's consider expanding x plus 3 and x minus 5. My preferred method is the grid method, like so. So in any order, let's work out what this would be if we were to expand these brackets. So this box here, x times x is x squared. X multiplied by 3 is 3x's. X times minus 5 is minus 5x. And finally, positive 3 multiplied by negative 5 gives minus 15. We now need to group this together and simplify. So, first of all, we have an x squared term. 3x minus 5x overall is minus 2x's, and of course we have negative 15. So simplified, x plus 3 multiplied by x plus 5 becomes x squared minus 2x minus 15. So these 2 last brackets we can simplify into this expression here. So essentially, when we're multiplying out these 3 brackets, we can think of it as being one of the same as doing x minus 1 multiplied by the whole of x squared minus 2x minus 15, because this is what these 2 brackets combined are equivalent to once they're expanded. So the final step is to do x minus 1 multiplied by the whole of x squared minus 2x minus 15. We can use a grid method again. This time though we've got 2 terms for this bracket and then 3 terms here, a squared term, an x term, and a constant term. So this time, using the grid method, we need to have an extra column because here we've got an extra term in this quadratic. So the setup should look something like this. So x squared minus 2x minus 15 here, and then x minus 1 down the side. So again, in the same way, let's expand these out. So x squared times x is x cubed. X times minus 2x squared. This is minus 15x. X squared multiplied by negative 1 is negative x squared. Minus 2x times minus 1, minus times minus gives a positive 2x. And minus 1 times minus 15, again, will give a positive 15. Simplifying the terms again, like we did first of all, we've got one lot of x cubed. Minus 2x squared minus another x squared is minus 3x squared altogether. The x terms, 2x take away 15x, overall is negative 13x. And of course, you have the plus 15 as well. So fully simplified, this is our answer. So in terms of ax cubed plus bx squared plus cx plus d, our answer is x cubed minus 3x squared minus 13x plus 15. Question 13 is a question on algebraic proof. What we need to do here is to prove that the sum of any two consecutive triangular numbers is a square number. And we're told here that a triangular number, the nth one, is n brackets n plus 1 all over 2. So consecutive means one next to the other. So what I'm going to suggest we do here is to consider the first number n, and the one after that will be one bigger, which will be n plus 1. So let's use this as our setup. Let the first number be n, and the next one n plus 1. So therefore, the sum of any two consecutive triangular numbers will be, if starting with n, we're going to have n brackets n plus 1 over 2 plus, then the next one will be n plus 1. So now we're going to have n plus 1 instead of just n. And then in these brackets here, n plus 1 will become n plus 1 plus 1, which of course we can simplify in just a moment, all over 2. Sum, of course, means added together, so that's why we're adding. Sum means add. So what we can do here is obviously expand and simplify. So n times n plus 1, that's going to become n squared plus n. So I have n squared plus n all over 2 for that one. And this one here, this is going to become n plus 1 multiplied by n plus 2. So if I just say all of this here, that's the same as n plus 1 times n plus 2. Because n plus 1 is, of course, n plus 2. And if I were to expand this out, I'd have n squared. N times 2 is 2n. 1 times n is 3n. And 1 times 2 is 2. If that was too quick for you, which may be a fair point, I'd suggest use the grid method for expanding brackets. But essentially, what I'm trying to say here is, if I expand out this top here, I'd get n squared plus 3n plus 2. So just write this in here, and again it's all over 2. Both fractions are over 2, which means I can combine them into a single fraction with a common denominator of 2. So if we do that next, n squared plus n squared will become 2n squared. N plus another 3n's will give 4n. And then I've just got a constant 2 to consider, like so. All of this is being divided by 2, and all these terms are even, so I can just half them all. Half of 2n squared is a single n squared, half of 4n is 2n, I mean to say. And then half of 2 is 1. Now, I need to show that this is a square number. So, essentially, I need to show this is something squared. This would factorize. So, I need to find two numbers that multiply to 1 and add up to 2. Those two numbers would be 1 and 1, because 1 times 1 is 1, 1 add 1 is 2. So, in other words, this is the same as n plus 1 squared. So, because n is a whole number, n plus 1 is a whole number, and I'm squaring it, which proves that this is essentially a square number. So essentially the proof's done, and we should conclude with a valid concluding statement. So just conclude by referencing the proof, what you were trying to prove. So therefore, the sum of any two consecutive triangular numbers is a square number. Sum of two consecutive triangular numbers. Help if I could write properly. Apologies. Sum of two consecutive triangular numbers is a square number. Let's now have a look at question number 14. Question 14, we've got that OAB is a triangle. OBC is a sector of a circle, centre 0. So we need to calculate the area of OBC. OBC means the sector as we go from O to B to C. So if I just highlight this in red, it's this sector here. So how do we work out the area of a sector? Well, a sector is best considered, I believe, as to be a slice of a circle. The full circle has an area of pi times radius squared, and a full circle's got 360 degrees going from the centre all the way around. This sector, however, is only 80 degrees of a total of 360 degrees that would make a full circle. So consider a sector as a fraction of a full circle. This one is 80 out of 360 of a full circle. So the area of OBC, relating to the radius which we don't yet know, has this formula here. Its area is this fraction of the full pi r squared. But of course we don't yet know the radius of this circle, well, this sector. We do know though that the radius would be from O to B, which is the same as from O to C. So if I just label from O to B, I'm going to call it side A for now. I'm going to explain why I'm doing this. It's because this here is a non-right angled triangle, and this here, therefore, we might be able to use either the sine rule or cosine rule. We can't use SOHCAHTOA because it's not a right angled triangle. If I find side A, that would tell me the radius, which should be really useful because I can use that value in this formula and then work out the area. So if I call this A, the length A opposite to that, I'm going to call the angle opposite to it capital A. So this here, 35 degrees, I'm going to call capital A. Then in any order, the other two sides need to be called B and C. So it doesn't matter which one we pick. So I'm going to go for B as 9 and C as 6. So is it going to be the sine or cosine rule we're going to be using? Well, the sine rule is used when we know an angle and a side opposite to it. We don't know that. We know this angle, we don't know that side. We know this side, but not this angle. We know this side, but not this angle. So if we don't know a side and its angle opposite to it, it's got to be the cosine rule. And the cosine rule is as follows. A squared equals b squared plus c squared minus 2bc cos A. There is a different version of the cosine rule for finding an angle, but because we're trying to find a side, we're using this version here, and A is the side we're trying to find. So if we just plug the numbers in, we're going to get this. We're going to have that A squared is b squared, which is 9 squared, plus c squared, which becomes 6 squared, minus 2 times b times c, which is 2 times 9 times 6, times cosine of A, which is 35. If we plug these numbers into the calculator, in fact I'll show you here, why not? We should get 9 squared plus 6 squared minus 2 times 9 times 6 times cosine 35. We're going to get 28.531 and so on and so on. Something like this. But that's A squared. We don't want A squared, we want just A. So what's the opposite of squaring something? It's going to be to take the square root. So if we square root both sides now, we can find A. Therefore, A, in other words, the radius, is 5.3414 and so on and so on. So now we can use this and plug it in to work out the area of OBC. So therefore, the area of OBC is this fraction times pi times that value squared. And if we type this in on our calculator correctly, we should find that the area of OBC, correct to 3 significant figures at least, is 19.9 squared centimetres. And that's our answer for question 14. Question 15 is factorising a squared minus b squared. This is just, if you spot it, it's dead easy. If not, it's almost impossible. This is called a difference of two squares. One squared thing, a times a, minus another squared thing, in this case b times b. What we do, if it's one square minus another, we add the squared things, the square root of the squares I should say. Square root of both of these is a and b, so a plus b. And in the second bracket, we write almost the same, but whatever comes after the minus here comes after the minus in the bracket. So we have a plus b, a minus b. Part b of the question relates to part a. We need to show that 2 to the power 40 minus 1 is the product of two consecutive odd numbers. So what we need to do here is we need to use part a to complete the question. This essentially is again difference of two squares, because 2 to the power 40 you can think of as being 2 to the power 20 squared, and the same as that, 1 is the same as 1 squared. So you can think of this as being, in fact I'll rewrite it, 2 to the power 40 minus 1 is the same as 2 to the 20 squared minus 1 squared. If we write it like this, it might seem more obvious. This is now the same as part A essentially. It's going to be 2 to the power 20 plus 1, and then 2 to the power 20 minus 1. So that's the first step. First step, we show that this is, again, a case of difference of two squares. The second step is then to actually evaluate what this means and show that, using careful logic, that this is the product of two consecutive odd numbers. So 2 to the power 20 just means 2 times 2 times 2, and so on and so on. It's a multiple of 2, therefore by definition this is even. So 2 to the power 20 is even both times. 2 to the power 20 plus 1 is therefore 1 more than an even number, so this one is odd. 2 to the power 20 minus 1 is therefore 1 less than an even number, and if you take an even number and take 1 away from it, of course you're going to get an odd. So it's just saying that in words, something like this would be what I'd suggest you do. 2 to the power 20 is even, so both 2 to the power 20 minus 1, in other words, this bracket, and 2 to the power 20 plus 1, this one, are both odd. So we've got an odd multiplied by an odd, which by definition is a product of two consecutive odd numbers. So therefore, 2 to the power 40 minus 1 is a product of two consecutive odd numbers. Say this clearly to conclude, to make sure you get full marks in the bag. Question 16, we have a transformation. In particular, it's an enlargement. We're enlarging triangle T by scale factor -2, centre of enlargement -2, -2. So I'm going to add the centre of enlargement on the diagram with a big red cross. So we're going to put the centre of enlargement on here. Next, I'm going to highlight the three main points of triangle T. I say the three main points, I mean the three only points a triangle has. So when we enlarge this triangle, the new points on the triangle will be along the line that joins each original point to the centre of enlargement and extended along. So if I do a straight line from the red point to the centre of enlargement in a dotted red line, I'll get this. Next one, if I were to do it for the blue, the new blue point will be somewhere along this blue dotted line, and finally the green point will be transformed to somewhere along this green dotted line shown now. So where do we know where it's going to go? Well, the key thing here is the scale factor. The scale factor is -2. The 2 tells us that the shape is going to be double as big after it's been enlarged, but the minus tells us that rather than the new triangle T being down here, the minus means the new shape is going to pop behind the centre of enlargement somewhere there. So essentially, this means it's going to be twice as big, but appears behind the centre of enlargement. So it's going to be double as big. Therefore, another way of thinking of this is the points are going to be double the distance from the centre of enlargement than what they are currently, but looking behind the centre of enlargement. So this red point here, currently it's 1, 2, 3, 4 squares away from the centre of enlargement. Times it by 2 is going to end up being 8 squares away. So this red point is going to be 1, 2, 3, 4, 5, 6, 7, 8. The new red point will transform to this point here. The blue point, currently, from the centre of enlargement down to the blue, is 1, 2, 3, 1, 2, 3, 4, 5. It's 3 down, 5 along. Multiply those values by 2 and made minus, we're now going to go 6 up and 10 along. So the blue point here is going to end up being all the way over here. It's going to be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like I've said. You can even use a ruler if you wanted to, measure this distance and double it to get there. Finally, the new green point is currently, it's 3 squares diagonally away from the centre of enlargement. Double that to 6. The new green point will transform to 1, 2, 3, 4, 5, 6. It's going to be over here. Now we have all our 3 points. The final thing is to just connect them dot to dot, and we then have our new triangle. So the final thing is just to draw the new triangle on, and then the job's done. That's question 16 complete. 17 is a distance time graph. So it curves upwards, as you can see, time on the x-axis as it were, distance going up on the y. Find an estimate of the gradient of a graph at time 2.5 seconds. The gradient is a straight line taken at a point on a curve, and the straight line can't actually cut the curve at the point, it just sort of scrapes alongside it. So I'm going to put a dot on where 2.5 seconds is. Then if we imagine I'm drawing a line that just touches the curve there, sort of like glances, touches and bounces off, the tangent would be sort of this line going in this direction. At GCSE it's not an exact art, so by eye, if you get a ruler and try to angle it correctly, I'll show you how I've done one in a second because I've pre-made the line. It'd be something a bit like this, I suspect. That obviously cut the line, that's too not steep enough. Maybe a line like this or something. So here's one I made earlier. That's my red tangent. Yours might be slightly different to mine, and the examiner will be okay with this, so long as your tangent is about the correct steepness. So for gradient, once we've got our straight tangent, we need to pick 2 points on it to work out the gradient. I'd suggest to use a point here which we've already been given, which is 2.5 along, and then the dot here is just before 1 square up from 20. So this would be 2.5 and 21. The next point I'm going to pick is, I'm going to go for this one here when the time is 4, because it seems to cross here at 48. So I'm going to highlight this one here in green. The gradient is a change in y over the change in x. So think about the change in y first. It's gone from a height of 21 up to a height of 48. So the change is 48 minus 21. And the change in x has gone from 2.5 to 4. So the change, this direction here, is 4 minus 2.5. If we actually work that out, 48 minus 21 is 27, and 4 minus 2.5 is 1.5. So to calculate the gradient, we're going to do 27 divided by 1.5, which gives 18. Part B asks us what the gradient of the graph represents. we need to know that the gradient of a distance time graph represents the speed. Alternatively, you could say velocity. The way I would remember this, the gradient is a change in y divided by change in x. So the units of the gradient will be the y units divided by the x units. Meters divided by seconds, in other words, is meters per second, and that tells us it's a measure of speed. So finally, to conclude for part B, we just need to say that the speed of a person or object is what it's measuring. And in brackets here, put down what your gradient would need to be in between to get full marks. 18 is ideal, but so long as your gradient of a tangent is between 16.5 and 19.5, that's sufficient to get full marks, so long as you've drawn it on and you've shown a method for calculating the gradient. So if you follow it through and get somewhere between 16.5 and 19.5, great. If you're outside of these boundaries, you may only receive 1 mark out of 2 for attempting the gradient. Question 18, we have a solid frustum. A frustum is a strange word. It just means essentially what you'd get if you took a pyramid or cone and cut its top off. So this one here is a small cone cut off from a large cone. So as shown in the diagram. So these dotted lines show where the original full cone would have been, and then this top little one's been cut off to leave us with this frustum here. It talks about the slant height of a small cone is 6. The slant height of a large whole complete original cone would have been 10 from top to bottom, and the radius of the base of a large cone is 3 here. We need to work out the total surface area of this frustum. Give your answer correct to 3 significant figures. And it's talking here in the formula we've been given about the curved surface area of a complete cone. Is pi times the radius times L, where L is the slant height. So first of all, let's consider the curved surface area of the frustum. What curved surface area would remain after we cut the top cone away from the full cone? Well, I would suggest that the curved surface area of the frustum is simply going to be the curved surface area of the entire cone minus the curved surface area of what's been removed, basically minus the curved surface area of the small one. So, for the large cone, pi is obviously pi, radius is 3, and the slant height, L, is this 10 here. For the small cone, we're told the slant height of this is 6, this one here. So, the curved surface area of the entire cone would be pi times 3 times 10, because the radius of the entire cone is 3, and the slant height was 10. But for the small cone, as I say, its slant height is 6, but how can we work out its radius? What we can do here, we can compare the slant heights of a full cone and the little one. 6 as a fraction of 10 is 3/5. And so comparing the slant heights of the little one to the complete one, we can see that as a fraction of the complete full cone, the little cone is just 6/10, in other words 3/5 of the full cone. So the length of the entire cone divided by the length of the small one is just 3/5. In other words, because the slant height of the small one is 3/5 of the slant height of a full one, in the same way, this radius here for the small cone will be 3/5 of the original radius of 3. 3/5 of 3 is 1.8, so therefore the radius of the small one is 1.8. So therefore the curved surface area of the small cone we need to take away will be pi multiplied by 1.8 multiplied by 6. And if we do this on the calculator, we should get a value of 60.31857, and so on and so on. So we worked out the curved surface area of a frustum, which I'm going to highlight now in this blue colour. However, the question doesn't ask us for just the curved surface area of a frustum, it asks us for the total surface area of a frustum. So we'll have like a curved bit going around the outside, all the way around, but also there's going to be 2 circular areas to work out too, this bottom circle and the top circle as well. So therefore the total surface area is a curved surface area, this bit here, plus the area of the base, plus the area of the top. So I need to work out the area of this bottom blue circle here, and the area of this one of colour-coded in pink. So the curved surface area is obviously 60.3185789. The area of the big one, big circle, is pi times 3 squared, and this circle here will be pi times 1.8 squared. So piecing these bits together, we're going to have this, and we need to give our answer to correct 3 significant figures. So if we add these 3 bits together and round appropriately, you should see that your final answer is 98.8 centimeters squared. Question 19 is about Sana, who needs to draw the graph of y equals 3 to the power x between x being 0 to 4 inclusive. She draws it on the grid as shown. She's done a nice job with the curve. However, she's done one thing wrong. Write down one thing Sana has done wrong. Well, this curve is 3 to the power x. So for example, when x is, let's say, 1, y would be 3 to the power 1, which should be 3. So when y is 1, we can see here we have got 1, 2, 3. That works. When x is 2, y should be 3 squared, which is 9. That works. 3 cubed, 27, yep. The main thing is if you look at the point when x is 0, then y should be 3 to the power 0, and anything to the power 0 is 1. So the first coordinate should be at the point 0, 1. However, Sana's done it going from the origin, which is incorrect, because 3 to the power 0 is not 0. So to keep it simple to the examiner, what I'd say is something just like this. The graph should begin at the point 1, 0, not at the point 0, 0. Question 20. Prove algebraically that the recurring decimal 0.123 recurring can be written as 61/495. Okay, so this one requires algebra. So what we need to do is to call the recurring decimal a letter. We can call it R for recurring, A, B, C, whatever. My tendency is just to call it X. So if we call X 0.123 recurring, then in brackets what I tend to do is just write out a few numbers, a few digits of what this decimal would look like. So 0.123 recurring, the recurring dots aren't above the 1, just above the 2 and the 3. The recurring pattern would be like this. It'd be 0.1, then 2, 3, 2, 3, 2, 3 indefinitely. I suggest now to draw a grid. So let's start working from the bottom and going upwards. So something like this, and these big looking bombs are just overly emphasized decimals. So first of all, let's just write down x at the bottom. So x is 0.1232323232, and so on and so on. What we're going to do now is to multiply by 10 and 10 and 10 again until we get to a row where we can see that the recurring pattern lines up with one of the earlier rows. So first of all, let's just take this number and multiply by 10. 10x would be 1. The decimal would move one place to the right, essentially. It would be 1.232323. 10x would look like this. We can see, though, these digits don't line up at all. Where there's a 3, there's a 2, and where there's a 2, there's a 3, so that's no good. So we need to multiply by 10 again. 10x times another 10 is 100x, and that's going to give us 12.32323232. So now the 100x line and the 10x line doesn't line up. But if you look at the 100x and the single x, 2 and 2, 3 and 3, from this 2 and that 2 onwards, they line up perfectly. So if I highlight here how they line up and are one and the same, this means if I were to do 100x subtract 1x, that will remove the recurring decimal part, and then we can go on and actually solve and prove what x is as an exact fraction. So the next move now is to do 100x subtract 1x. So if we do this together, 100x minus 1x will obviously give 99x. And then all these numbers here are going to cancel. So if I just show you that quickly, this cancellation pattern like so, then again, we'll have 99x equals, after all this cancellation, we're going to have 3 minus 1, which is going to be 2. And then 2 take 1 is 1. Finally that one, or just 12 minus 1 is 11. So in other words, 99x is going to be 11.2 when we do subtraction. So therefore, x itself will be 11.2 over 99. Now that, of course, looks nothing like what we're trying to prove. We can't really have a decimal within a fraction. Well, we can, but it doesn't look the best. So to get rid of this decimal, let's multiply both top and bottom of this fraction by 10. If we do that, 11.2 multiplied by 10 gives 112. The bottom becomes 990. And finally, we can now half both top and bottom. So if we now divide by 2, we get exactly what we need. Therefore, the question's complete. Half of 112 is indeed 61, and half of 990 is 495. Therefore, we've proven it, and we're done. Question 21, we need to solve this algebraic fraction question. We're adding 1 over x plus 4 to 3 over 2 minus 2x, and needs to equal 1. So I'm going to treat this as though we're adding two numerical fractions together, and if we're adding two fractions, the numerators need to be the same. So what I'm going to do here, I'm going to take the x plus 4 here and multiply the top and bottom of the second fraction by x plus 4. In the same way, I'm going to take the denominator of the second fraction, the 2 minus 2x, and multiply the top and the bottom of the first fraction by that. That will then have the effect of making the denominators of both these fractions x plus 4, brackets, multiplied by in brackets 2 minus 2x. In other words, they'll both have the same denominator, a mixture of both the blue and red bracket. So the next step, after performing these operations on the numerator and denominator, the fractions will now look like this. So the top will just be 2 minus 2x for the first one. The numerator will now be x plus 4 multiplied by 2 minus 2x. Then adding this second fraction, so that's going to be 3 lots of x plus 4. Again, it's going to be over x plus 4 multiplied by 2 minus 2x, and that, of course, is equaling 1. Because both fractions now have the same denominator, I can now combine them into a single fraction. So now I'm going to put this all over x plus 4, 2 minus 2x. And on the top, we're going to have 2 minus 2x. Expand this one, we get plus 3x plus 12. Let's move this fraction up, but don't need to put it so low. That's going to equal 1. So now I'm going to do, I'm going to rewrite 1 as 1 over 1. I'm going to explain how I'm going to do this. Essentially, by writing 1 as 1 over 1, which is what it actually is, I can hopefully see that if this numerator is the same as the denominator, but this fraction here is equal to this one on the left, then in the same way, this top here, this numerator, must also be the same as this denominator. So therefore, this one here must be the same as the green, because the numerator and denominator here are also the same. So now we can say the top, which we can simplify now actually, minus 2x plus 3x is a single x. So that means that a single x and 2 plus 12 is 14. That must equal the denominator, which is x plus 4 multiplied by 2 minus 2x. The next step is to expand these two brackets, the x plus 4 and the 2 minus 2x. And just for speed, I've done this in the corner here. If I multiply out x plus 4 by 2 minus 2x, I'd get the following, and therefore that's going to give me an overall minus 2x squared minus 6x plus 8. So I can then say x plus 14 equals minus 2x squared minus 6x plus 8. I now need one side of the quadratic to be equal to 0 if I'm going to solve it. So my suggestion now is to subtract the x and the 14 from both sides. So if I minus x plus 14 from both sides of this equation, that'll now give me the next line, which will be equal to 0, which is probably a decent move to have made. And I have minus 2x squared Minus 6x minus another x is minus 7x's, and then this 8 minus another 14 now gives minus 6. At this stage, what I'd suggest we want to do is to multiply by negative 1, because a quadratic just makes more sense in my mind when the x squared term is positive. I then get that 2x squared plus 6x, plus 7x, my apologies, plus 6 equals 0. I'm now going to show you how I can solve this without the calculator. I'll then show you as well how to use the calculator to solve it if you have a high-powered enough calculator, that is. So, I think I'm the bane of our maths team here, but the way I factorise these is a bit hacky, but I think it's pretty cool. What I'm going to suggest we do here, we just take the 2, multiply by the n number of 6, and then we think of it as being x squared plus 7x plus 12, and factorise this as normal, if you like. So factorise this one like an easy one. Two numbers that multiply to 12 and add up to 7 would of course be x plus 3 and x plus 4. However, we conveniently just forgot about this 2, didn't we? So what we now do is we stick this 2 back under the numbers in these fractions, in these brackets. If a fraction can simplify, we do that. If not, and there's still a denominator that remains, we then shift the bottom number in front of the x. 3 over 2 doesn't simplify, so I just move a 2 in front of the x like so. 4 over 2 does simplify, it just becomes 2. So fully factorised, we have 2x plus 3, x plus 2 equals 0. Therefore, if this bracket would be equal to 0, x would have to be 2x would equal negative 3, because minus 3 plus 3 would then cancel. If 2x is negative 3, x would have to be minus 3 over 2. Or perhaps x could be equal to minus 2, because minus 2 plus 2 again would make this bracket equal to 0. So in other words, x is either minus 3 over 2 or minus 2. And I did say I'd show you how to do this on a calculator. Different versions have different methods, but essentially it should be very similar to what I'm about to show you here. On this particular version of the Casio, we can press Menu and press Option A, or scroll along until we get to an equation / function button. Press equals. We want it to be a polynomial, degree 2, because it's a quadratic, which is something squared, hence the 2. If it was a cubic, it'd be pressing number 3, but we press number 2. So we want to solve 2x squared plus 7x plus 6 equals 0. So we type in 2, then press equals, 7, then press equals, 6, then press equals. Press equals again. Our first answer it gives us nicely, and the second answer it tells us as well. So as long as you're clear to the examiner that you've used your calculator at this step, I'd probably just say in brackets use my calculator, you should get full marks, because it is a calculator paper and it doesn't explicitly say that you need to show every algebraic working step. So again, this is just a nod to you guys at home, guys and girls of course, that if you are very comfortable and knowledgeable with your calculator, you can extract more marks and hence a better grade from your exam. So it's not just a case of having a calculator, it's knowing how to use it intelligently, which I believe is a skill in its own right. Let's have a look now at question 22. We've got here, given vector A, 2, 6 and B, 8, 2 is parallel to this one, find an expression for B in terms of A. So what we need to know is if two vectors are parallel to one another, then one can be expressed as a multiple of the other. So what I'm going to do first of all is just rewrite this as a different looking vector. Vectors, if you have a scalar, just a number on the outside, multiplied by a vector, it can be expanded in much the same way as expanding a linear algebraic bracket. So I can multiply this A by the 2 on the top and the A by the 6 on the bottom. That gives me 2A, 6A, and then this one, similar with the B, I can call this B times 8, 8B, then b times 2 is 2b. So in other words, this vector plus that one must equal some multiple of the other one. So whatever you want to call the other one, I'm just going to call it another letter. So this is A and B, and we're going to call this C. 13 times C, 6C. C is just some unknown number. So the key thing here is the concept. If two vectors are parallel to each other, then this one combined, is one multiple of the other. So I've just wrote this one here as 13, 6 multiplied by C. So now we've got this top line must equal 13C, and 6A plus 2B must equal 6C. So from these two bits here, we can actually extract two simultaneous equations. I've got this, and 8B, which must equal that. Top plus top must equal that top one. And in the same way, this bottom bit here, 6A plus 2B must equal 6C. So we can now go from talking about vectors to talking about simultaneous equations. So 2A plus 8B equals 13C. And on the bottom, 6A plus 2B equals 6C. So how can we solve these now? We're not really interested in C. The question here is saying find an expression for B in terms of A. So what I'm going to suggest we do is we eliminate C. So let's get the numbers in front of these C's to be the same. So in other words, what's the lowest common multiple of 13 and 6? Well, one thing we could just do 13 multiplied by 6. That would work, and that would give us 78. In other words, I can just multiply the top by 6 and the bottom by 13. And if I do that, what I'm now going to get is the next line. So I'm now going to have 12A. 8 times 6 is 48, so 48B. 13 times 6, as I've said, will be 78, so it becomes 78C. On the bottom, multiplying through by 13, that's going to give me on the bottom 78A. 13 times 2 is 26, so that gives me 26B. Again, will equal 78C. I want to eliminate C because I'm not interested in C, like I've said before. I just want something relating B and A together. So what I'm going to do here is do one line, take away the other, because both these 78C's are positive terms. That's positive and that's positive, and the signs are the same, we subtract. So now what we're going to get is 12A minus 78A. So 12A minus 78A, if in doubt use your calculator. I think it's probably safe when dealing with negative numbers. So 12 minus 78 minus 66. So minus 66A. 48 minus 26. 22. So we have minus 66A plus 22B equals 0. We want an expression for B in terms of A. So what we're after is it in terms of B equals something. So B equals something to do with A. So from this stage here, to get B on its own, I'm going to add 66A to both sides. So plus 66A to both sides. This equation will now transform to 22B equals 66A. Finally, dividing through by 22, we see that B must equal 3 lots of A. And that's question 22 complete. fairly challenging, but it is almost the end of the exam here, which is why the questions are ramping up in difficulty. Question 23, in my opinion, this one's the hardest question on the whole paper, harder than the last. We're told a circle's got equation x squared plus y squared equals 25. So let's begin with this. So we need to, I would say, to draw out the circle, sketch it, then we can picture the problem better. So let's draw a circle on coordinate axes. This one here, this is an equation of a circle at the centre of the origin, and if it's in this form, x squared plus y squared will equal the radius squared. So 25 is its radius squared. In other words, square root of this is the radius of the circle. This is going to be the radius of a circle of 5. So if I label on here, that's 5. Next, we're told that the point P with these coordinates lies on the circle. So what I'm going to do now is add on this point, minus 3 and 4, which means x is negative 3 and y is 4 at that particular point. Alex then mentions about the tangent of circle at P crosses the x-axis, he thinks, at minus 8 and 0. So let's draw on the tangent to a circle at P. It's going to be a straight line that just glances off the circle at this red point and carries on. So it's going to have a negative gradient, something along this line here. Here's one I sketched on earlier. So now it's a case of thinking, is Alex correct? Well, you need to show how you get the answer, but more than that, where to even begin. The key thing here is having to remember that the radius meets a tangent at a right angle. We need to remember that, and that's our first easy mark, I would say. So, because the tangent meets the radius at a right angle, that's to say that the tangent's gradient will be the negative reciprocal of the gradient of this blue radius. The gradient of a radius, from the origin going up here, it's gone up 4, but it's gone back in terms of x by minus 3. So the gradient of this blue radius is 4 over minus 3, which, to be fair, I could have said is minus 4 over 3. Now, the negative reciprocal of that will tell us the gradient of a tangent. So if I flip this fraction on its head and change its sign from minus to positive, we can see that the gradient of a tangent must be positive 3/4. We can now start about thinking about what the equation of this tangent is. The general equation of a straight line, and a tangent is a straight line, is of course y equals mx plus c. But we do know a y value and an x value that this tangent goes through, because it goes through minus 3 and 4. So highlight y and x in red, and fill in now that when y is 4, x is minus 3, and I can also sub in this gradient here, because the gradient of a tangent, we've now deduced, is 3/4. So filling in m as 3/4, y as 4, and x as negative 3, we get this next step. 4 equals 3/4 of minus 3 plus c. So let's work out what c would be. 3/4 times minus 3 is of course going to be minus 9 over 4. So I need to get c on its own. So if I add 9/4 to both sides, 4 plus 9 over 4, that will tell us what c is. C is, in other words, 25 over 4. So the next step, by adding 9 over 4 to both sides, we get that c is 25 over 4. Therefore, the equation of a tangent is y equals 3/4 of an x plus 25 over 4. That would be a hard enough question as it was, but even then we're not done, because Alex is now saying that the tangent crosses the x-axis at the point minus 8 and 0. So now, let's see if that holds true. We can now sub in when x is minus 8 and see if y is equal to 0 or not. So this is our final step. We're going to sub x is negative 8 and see if y is 0. So sub x equals 0. Sub x equals 8, I mean to say. We're seeing if y will be 0. Y is going to be 3/4 times 8. Well, 3/4 of 8 is going to be basically, sub minus 8, get it right. Y is going to be 3/4 times minus 8, which will be minus 24 over 4. plus 25 over 4, which gives a quarter, which is not equal to the 0 that Alex said it would be. So in other words, we've shown that Alex is wrong. When x is minus 8, y is a quarter. So the tangent is actually slightly above the x-axis when x is at negative 8. So therefore, we need to just conclude Alex is incorrect. It's now time for the last question, but I honestly don't think it's quite as evil as that one. Question 24. There's a total of y counters in a box. X are pink, 5 are blue. The rest are green. We're told that the ratio of x to y is 1 to 3, and Freda takes at random 2 counters from the box. Find in terms of x an expression for the probability that Freda takes 2 counters of the same colour. Give your answer that it's a fraction in this form, where a, b, c, d, and d are all integers. We're told there's a total of y counters, so let's begin with that. We're also told next, x of them are pink, 5 are blue, the rest of them are green. And the ratio of x to y is a ratio of 1 to 3. So in other words, the number of pink counters is just 1/3 of the total of counters. So if the total number of counters is y, y must be 3 times bigger than x. In other words, y equals 3x. So we can now fill in, algebraically, how many pink, blue, and green counters there are. So the pink counters, we have x. For blue counters, we've got 5 of those. And for total counters, in terms of x, we've worked out as 3x. The rest of them will be green. So x has already gone, so I need another 2x here. But I want it to be just a total of just 3x, nothing to do with this 5. So I need to minus that 5 off. So the green counters must therefore be 2x minus 5. Let's double check. Add all these up, it will give 3x. We can now actually set out the question and go from there. So this is the main thing. The probability of picking a counter of the same colour, there's 3 ways of doing it. You could pick a pink and then a pink. I'll explain why I'm going a bit crazy saying and loudly and highlighting it in big red and bold. Or, again, bold in capitals, could be blue and blue. Or we could have green and green. I'm putting emphasis on and the or because and with probability will universally work as a multiplication, and or is a massive clue that we're going to add probabilities together. So pink and then pink. Let's think about this step by step. It's going to be lots of fractions added together. So what would be the chance of picking a pink one first? Well, the total pink counters is x, and the total counters altogether is 3x. So the chance of picking pink first would be x over 3x. These counters aren't replaced, so to pick a pink one next, there'd be one less pink to choose from. So then there'd be x minus 1 pinks, and the total number of counters would have also decreased by 1. So the chance of picking another pink next would be x minus 1 over 3x minus 1. And works as multiply. So we have x minus 1 over 3x minus 1. Or, so now we add the probability of blue and blue. The chance of picking a blue first would be 5 out of a total of 3x's. But we multiply that by 4, because now there'll be 1 less blue. 1 less than 5 is 4. And 1 less counter in total, 1 less than 3x, becomes 3x minus 1. Finally, or, so we add the probabilities of green and green. To pick a green first, there's 2x minus 5 greens as a fraction of 3x. So picking a green first will be 2x minus 5 out of 3x. Then multiply that by 2x minus 6, because that will become 1 less, the numerator. And similarly, the denominator will become 3x minus 1, because that becomes 1 less than its original self, 2. So this is what we've got, which looks absolutely evil. But actually, if you look here, the denominators are repeating. So all of this is going to be over 3x multiplied by 3x minus 1. So the first bit, fraction times a fraction, we just times the tops and times the bottoms. So the first fraction set becomes x brackets x minus 1 all over 3x minus 1, and that denominator is the same for each. This new numerator, 5 times 4 is 20, and then this one over here, 2x minus 5 multiplied by 2x minus 6. We can now look at these numerators and simplify and expand. The pink expands to x squared minus x, 20 we can leave as 20, and 2x minus 5 multiplied by 2x minus 6. You might want to use the grid method to do this slowly and properly and carefully, but if you expand out these brackets, you should get 4x squared minus 22x plus 30. Now it's just a case of trying to simplify the numerator, and the denominator is already in the correct form. D is 9 and E is minus 3x. So it's just a case of now neatening up the top so it looks in this form. So how many x squareds do we have? Well, in red, I'm going to ring the x squareds. X squared plus 4x squared will become 5x squared. The x's, I've got minus 1x here, minus another 22, that'll become minus 23x's, and the numbers on their own, I've got plus 20, plus another 30, that'll become plus 50. So the fully simplified numerator becomes 5x squared minus 20x plus 50, all over 9x squared minus 3x. That's question 24 complete, and since that's the last question, that's the whole paper done and dusted. I hope you found that useful. Do always bear in mind, you never expect to get every single question perfectly right every single time. 100% is overkill for a grade 9. These questions are hard, so it's a case of checking you understand them, and if not, asking your teacher for more help and getting similar questions to work on as well. Thank you anyway for listening. Take care, and I'll see you soon for the next video you tune into. Thank you once again, of course, for listening in the first place.